In today's episode, we will explore lists in Python. We'll learn how to create, modify, slice, and copy them, among other topics like the difference between shallow and deep copy. Let's get started. Lists are data structures that store ordered and indexed collection of elements. These elements can be of any type, for example, strings, integers, and many others. They allow access to the stored data using indices, which represent the position of the list's element starting from 0. They also offer a range of built-in functions, which we will briefly discuss shortly. The simplest way to create a new list is by using pair of square brackets, which will create an empty list of length 0. If you want the list to contain data, place the elements between the brackets separated by commas. For instance, short strings. Since list elements can be any type, they can also include other lists. These allow for nested structures with virtually unlimited levels of complexity. It's worth mentioning that the list elements don't need to be the same type. Each element can be a completely different kind of object, even very complex one. However, it's the programmer's responsibility to ensure data consistency to prevent errors. As mentioned, access to the list element is provided via indices representing the position of each element. These indices start from 0, so the first element has index 0 and the last element has an index equal to the length of the list minus 1. Negative indexing is also possible, referencing elements from the end of the list. In this case, the last element is always accessible at index minus 1, and the first element can be accessed with the negative length of the list. To retrieve a specific list element, place its index in the square brackets following the list's name. You can use both positive and negative indices depending on what is most convenient. Beyond single elements, you can retrieve a subset of the list, called a slice, by specifying a range of indices separated by colon. If indices are omitted, Python defaults to the first and last indices of the list. Providing no range will return a copy of the entire list. If you provide only the end index, the slice will include elements from the start up to, but not including the specified index. Negative indices can also define slices. For example, the following creates a slice that includes all elements except the last one. Additionally, Python offers an optional step parameter specified after a second colon. It determines the interval between elements in the slice. By default, step is 1. By specifying a step of 3, for example, would select every third element. Using a negative step reverses the order of selection, starting from the last element of the range. You can also specify a range with a step, such as selecting every second element from index 2 to index 5, but excluding index 5 itself. So far, we have focused on creating and accessing list elements using various indexing methods. However, indices can be also used to assign new value to specific element. This is not limited to a single element. Slices can also be modified by assigning new value in the form of a list. The slice being replaced doesn't need to match the length of the replacement. The original slice will be replaced as shown in the examples. Python provides a variety of built-in functions and methods to use with lists. One such a function is len, which returns the length of an iterable object like a list. Lists have many useful methods. For example, append adds a new element to the end of a list. Another method, extend, appends all elements of another list to the original list. You can use also insert to add an element at specific position, shifting existing elements to make room. The pop method removes an element by its index and returns it. The remove method deletes the first occurrence of the specified value. To delete elements by index or range, use the del statement. The clear method removes all elements, leaving an empty list. Other helpful methods include index, which returns the position of the first occurrence of a value, and count, which counts how often a value appears. The sort method orders the elements in the ascending order by default or descending order if the reverse parameter is set to true. The reverse method reverses the order of elements in place. List supports convenient operation like concatenation using the plus operator. List can be also multiplied using the asterisk operator to repeat elements. You can also check if an element exists in the list with the in operator. Python includes a powerful feature called list comprehension for creating new lists elegantly and efficiently. These expressions iterate over sequence and apply operation to each element. For example, we can create a new list by adding 10 to each element in an existing list. You can also filter elements to include in the new list by adding if condition at the end. Copying list can be done in several ways. The copy method creates a shallow copy. Alternatively, slicing can achieve the same result. The list function also creates a copy. It can also convert other iterables into lists or create empty lists. The problem with copying lists arises when their elements are more complex objects. The copying we've done so far only copied the reference to each element. If such an element, for instance, is itself a list that we can edit, any changes to it will be reflected both in the original list and its copy. This type of list copying is called shallow copying. The solution to this problem is called deep copying. However, to perform it, we need to use an additional Python module that provides extra functions, particularly the deep copy function from the copy module. At this stage, we won't go into details about modules and how to use them. For now, it's enough to know that the module is the collection of tools prepared by other programmers. To use a module, we first need to use the import keyword followed by the module's name to make it available in our application. In our case, the deep copy function, instead of copying only references to the elements, creates copies of them, meaning entirely new objects in the computer's memory. In today's episode, we explored lists in Python. We learned how to create, modify, and work with them effectively. That was a solid dose of knowledge. If you have any questions, feel free to leave them in the comments. That's it for now. Thank you for watching and see you in the next video.